And welcome back to the YouTube channel. So today's going to be the first of many series. Basically, I'll just be recording myself solving a lot of LeetCode questions. Mostly like a single LeetCode question a day. So today we have our first question. Uh, Given a non-negative integer x, return the square root of x rounded down to the nearest integer. The returned integer should be non-negative as well. You may not use any built-in exponent function operator. For example, do not use par x 0.5 in C++ or x exponent raised to power 0.5 in Python. Okay, so basically, let's say we are given an input of 4. We know the square root of 4 is 2, and let's say we are given an input of 5. We know the square root of 5 is approximately 2.36. We're supposed to return um 2 for both cases. So like even if it's a fraction, there's a decimal part with the number, we're supposed to round it down to the nearest integer and return it. So in this case, 5 will return 2. Okay, we can use the normal methods, these shortcuts. So basically to start, we know that if you have 0 and 1, the square root of 0 and 1 is always going to be, what's it called, the number itself. So we could just get started with that. So if x is greater than, it's less than or equal to, we don't have to factor in negative numbers. So they're just positive numbers. So if x is less or equal to 1, the number will either be 0 or 1. So we can just return x for that value. So then our else scenario will be the case in which x is greater than 1. So like an x is 2, 3 upwards. So with this case, we are going to solve anything with x greater than 2 with what's called the binary method, or the binary search algorithm. So basically what we are trying to do is we are going to try to create a range of numbers. Let's say 1, 2, 3, then 4, let's say 5. So the beginning will be from 1, then the end will be the number we are supposed to find the square root of. So if, let's say, we are supposed to find the square root of 5, the binary search method works in a way that we are going to find the midpoint between the beginning points 1 and 5. So in this case, the midpoint would be 3. So when we get the 3 and we square the 3, a square of 3 is 6. Sorry, a square of 3 is 9. So what we are going to do is, since 9 is greater than what's called 5, that means that 3 can't be the square root of 5. So that means that anything above here can't possibly be the numbers. So we will then push our end value to what's called the midpoint, the number before the midpoint. So like basically now our options become 1 and 2. So like it's basically halving the number of operations we would have to go through to find our value. Because in a normal simple for loop, we'd have to run 1 squared, 2 squared, 3 squared, 4 squared before you can find a number which is actually not greater than 5 and not less than 5. So like it gives you in between, either gives you the exact number 5 or it gives you something a little bit close to 5 but not greater than 5. So with the binary search method, the first thing we are going to do is we have to set our start points and our end points. So we're going to set the low and the high. So as I said earlier, sorry, my mouse, low and a high. So low point is the 1, that's the beginning point. Then our high point is the x. So like the value we're trying to find the square root of. So like basically this is kind of like a range in a sort of, we have a low point and a high point. Then we are saying while the low is less than or equal to high, So that means that as long as we've not run through all the values in the data sets, like in the set of numbers between 1 and x, there's a for loop. You're going to try to trim down the number of values we have to look at. So like the midpoint, as I said earlier, with the 1 to 5, 3 being the midpoint will be the, low plus the high floor 2. So like this will give us the midpoint. So basically, if low is 1, then high is, let's say, 3. So like the midpoint to be 3 plus 1, 4, divided by 2, that's like 2. But if there was a case where there was a remainder like 2.5, 2.6, we'll get 2. So like the 2 division sign is basically going to give us the value down, the closest integer down. So we are rounding it down. Then we see once we get the mid value, if the mid squared, so like if we square the mid and is equal to, so if you're lucky enough in our first iteration, we square the mid and we get x, we can just return the mid as the square root. Return mid. And if mid times mid is greater than x, so let's say we run the mid, we get the mid value, then we square the mid and it's greater than x, that means that what's called, we are out of line. So like that number can't be was that number what's called the square root of x. So basically we have to trim the numbers we are looking at down. So like basically with the 1 to 5 concept, 1 2 3 4 5. So let's say we had 3 squared as 9, which is not equal to 5, which is way greater than 5. So 3 4 5 can't be the square root of 5. So we'll trim our data sets, the number set we are looking down to 1 and 2. Yeah, so like basically this is the same concept. So if we square the mid value and the square is greater than x, that means mid can't be the square root of x. So you trim down our data set. So like we make high equals to mid minus 1. So it's 1 down the mid value. Else, so in this case, that's when, what's it called? You have a value which is, let's say we have 1 2 3 4 5. Then we had 3 squared less than 5. So that means that it's too low. So we have to trim 1 2 3. Then our data set under consideration will be 4 and 5. So low would be equal to mid plus 1. So in the case where we run through the loop, then we don't get a value. Then the highest point, the point this loops breaks is when the low is greater than the high, and we are supposed to round our integer down. So like the highest possible value would be the high in that case. So we return the high. So I think this will be a little bit confusing. So let me explain it with the concept of 3. So let's say we had 3, then we had low as 1, then high as 3. Then okay, low 1 is less than or equal to 3, so 1 is less than 3, so the loop runs. Then the mid will be 1 plus 3 4 divided by 2, so the mid will be 2. So if mid squared, oh sorry, it's supposed to be 2, there's no JavaScript. So mid squared 2, it's 4, and 4 is greater than 3, so this wouldn't run. Then we come here, mid squared is 4, 4 is greater than x. So now we'll trim the high to mid minus 1. So now the high becomes, the mid is 2. So high becomes 1. So now our data set under consideration is 1 and 1. Then we run the loop again. Whilst 1 is less than or equal to high. So 1 is less than or equal to high. So mid equals to 1 plus 1. So like 2 divided by 2, we get 1. So now our mid is 1, then our high is 1, our low is 1. If mid squared is equal to x, mid squared, 1 squared is not equal to 3. So the first doesn't run. The second is if 1 squared is greater than x, 1 squared is not greater than 3. So this doesn't run. Then else low equals mid plus 1. So now low becomes 2, then high becomes 1. But while low was our loop only runs when low is less than or equal to high. So at this point, when the loops break, the probable answer is only what's called 1, because 1 squared will give you a number which was lower than 2 squared. 2 squared, the new low squared. The new low squared will give you 4, but the high square will give you 1. So that is a reasonable answer. So this is basically the code for this solution. If we submit it, sorry, network issues. Let me connect. Okay, connect my network and try resubmitting. So in this case, I think it should connect by now. Okay, we're connected. So resubmit. Yes. So basically, the network is a little bit slow, but it should work. It should work. The whole concept is reasonable. Okay, accepted. Yes. So this is basically how to solve the square root of a value x based on their criteria with the binary search method. Okay, thank you.